Welcome to the second part of this AI course. We're going to look at different schools of thought in artificial intelligence. We talk of human intelligence as one thing, but according to Edward Gardner, an American developmental psychologist, there are 8 categories of intelligence. One of the categories, introspective intelligence, deals with understanding what you feel, what you want, and learning from mistakes. This is very hard to replicate with AI. Introspective intelligence essentially makes machines self-aware. AI scientists have proposed several models or schools of thought for human thinking that could be used in the development of artificial intelligence. The 3 main ones are symbolism, connectionism, and behaviorism. Let's look at them individually. Symbolism was mainstream for a few decades, starting from the early days of AI in the 1950s until the 1980s. It has several names. It's also called classic AI, rule-based AI, my favorite, good old-fashioned AI. Many AI experts still believe that symbolism can play an important role in AI development. Symbolism aims to create machines that absorb human knowledge and are able to process this knowledge as data. In symbolic AI systems, human knowledge, or data, is transferred to computers by means of symbols. Symbolic AI manipulates data in the form of symbols representing humans, cars, or other concepts. One of the main advantages of symbolic AI is that it processes information almost mathematically, the way a computer is designed. Symbolism gave rise to object-oriented programming in which data is processed according to if-then rules. An expert system providing medical diagnostics by asking questions to patients is an example of object-oriented programming. Let's turn to connectionism. Connectionism postulates that human thinking in machines can only be achieved if computers emulate biological processes. To replicate human thinking, computers need to be programmed like human brains, which means arriving at different answers to the same problem on the basis of new knowledge being acquired. Connectionism is the school of thought that underpins deep learning in artificial intelligence. In practice, connectionism takes the form of artificial neural networks, systems that emulate how neurons operate in our brains, including even their degradation over time. To get an idea of how connectionism works, let's see if a machine can understand what a red apple is. It's a bit like trying to guess something by asking questions. Is the object red? Is it round? Is it perfectly round? And adding weights to each new piece of information. Then, by summarizing the bits of information, you get the predicted answer, a red apple. Let's now look at behaviorism. The behaviorist school has a long history, dating back to the early 1900s. It posits that intelligence is a process of perception and reaction that is achieved through interactions with the surrounding environment. Behaviorism is also called evolutionism. Its basic principles are reward and punishment control mechanisms. As we saw earlier, AI development began in the 1950s. At that time, even if it was still early days for computer processing power, the scientific community and industry were all optimistic that AI would become a reality within a short period of time. But AI has not progressed in a smooth way since the 1950s. By the 1970s, many projects were abandoned. One example of a project that many had great hopes for, but failed, was machine translation. After that, and other failures, a lot of resources were pulled away from AI. From the early 1970s, for 2 to 3 decades, not much has happened in the field of AI. This changed in 1997. That was when a behaviorist IBM chess playing system called Deep Blue defeated the reigning chess champion, Garry Kasparov. The event re-energized the small community of researchers who still believed in artificial intelligence. The British-Canadian computer scientist Geoffrey Hinton and his research group proposed in 2006 the deep learning model for artificial neural networks. This set the stage for new types of sophisticated AI algorithms. Once again, there's a general belief in the computer science community, as well as in the public at large, that AI is entering a golden age. And that's it for this part of the course. In the next section, we'll look at strong versus weak AI.